February 1942, Melbourne, Australia. The telegram arrived at Army headquarters on a Tuesday morning, and the words on the thin paper made grown men's hands shake. Singapore had fallen. The fortress Britain promised could never be taken was gone in just 7 days. Japanese forces now controlled the entire region, and their ships were heading south toward Australia. General Vernon Sturdy stood in his office, staring at a map on the wall. Red pins marked enemy positions. They seemed to multiply every day, creeping closer and closer to Australian shores. The numbers told a story of complete disaster. Across the entire Australian continent, a landmass nearly as large as the United States, only 65 tanks remained operational. 65. Britain's Prime Minister, Winston Churchill, had taken everything else, shipping 90% of Australia's armoured vehicles to fight in the North African desert against German forces. He had promised to send them back if Japan attacked. That promise now seemed as empty as Australia's tank depots. The few American M3 Grant tanks that President Roosevelt pledged were still somewhere in the Pacific Ocean, trapped aboard slow-moving cargo ships that had to zigzag to avoid Japanese submarines. Nobody knew when they would arrive, or if they would arrive at all. The situation grew worse with each passing day. Intelligence reports showed Japanese forces assembling invasion fleets. They had aircraft carriers, battleships, and thousands of troops ready to land on Australian beaches. Australia's army had brave soldiers, but almost nothing to stop enemy tanks. Military planners ran calculations that kept them awake at night. If Japanese armour landed on Australian soil, the defence would collapse within weeks, maybe days. Then the American tanks finally started arriving in March, and a new nightmare began. The M3 Grant looked impressive rolling off the transport ships. It weighed 30 tons, had thick armour, and mounted a 75mm gun. American tank crews in Europe praised it. The American War Department had promoted the M3 Grant as their proven desert fighter, a tank that had performed well against German forces in the North African desert campaigns. Roosevelt's military advisors assured Australia these were exactly the right tanks for hot, sandy conditions. The M3 had survived Egypt and Libya, so surely it would handle the Australian outback, but Australia was not North Africa. The outback was different from any desert battlefield the Americans had ever imagined. The problem started immediately. In the desert north of Alice Springs, temperatures climbed to 120 degrees Fahrenheit. Inside the M3 Grant tanks, the heat became unbearable. The metal hull trapped heat like an oven. Crews couldn't touch the interior surfaces without gloves. Their skin would burn instantly. The engine overheated within 45 minutes of operation. Coolant boiled over. Radiators cracked. Mechanics stood beside broken tanks, wiping sweat from their faces, shaking their heads in frustration. The red dust created even worse problems. The fine, powdery soil of the Australian outback was like nothing American engineers had encountered. It was finer than sand, more abrasive than grinding powder. The dust infiltrated everything. It clogged air filters within hours. It ground away at engine seals. It jammed gun mechanisms. Tank crews would start their morning with clean machines and end the day with equipment that barely functioned. One officer wrote in his report that the American tanks were designed for European mud and rain, not for Australian heat and dust. In the conditions where Australia actually needed to fight, these expensive imported machines were nearly useless. At military planning meetings, senior officers argued about solutions. Most of them had trained in Britain. They believed in British military doctrine. That doctrine was clear and absolute. Tanks must be manufactured in proper industrial nations like Britain, America, or Germany. Colonies like Australia didn't build tanks. They didn't have the factories, the steel mills, the specialised knowledge, or the skilled workers. Building a tank from scratch required years of preparation, thousands of trained engineers, and industrial infrastructure that took decades to develop. The experts calculated it would take 3 to 5 years to establish Australian tank production. Australia didn't have 3 to 5 years. The Japanese were coming now. Some officers suggested Australia should simply wait for more American tanks and hope engineers could modify them for outback conditions. Others proposed importing British designs and trying to build them in Australian factories. Every suggestion seemed inadequate. Every plan required too much time or too many resources that didn't exist. Then Colonel William Dick Watson spoke up in a meeting and the room went quiet. Watson was 41 years old, tall and lean, with the weathered face of someone who had spent years working outdoors. He wasn't a career military officer from a prestigious academy. He was a railway engineer who had been called up when the war started. He knew nothing about tanks. He had never designed military vehicles. He had never even been inside a tank factory. The professional soldiers in the room considered him an outsider, a temporary amateur, playing at being an officer. But Watson had spent 20 years building and repairing locomotives in the Australian outback. He understood heat. He understood dust. He understood what happened to machinery in extreme conditions. He had watched railway workers keep steam engines running in temperatures that would kill most men. He had seen Australian engineers solve problems that European experts said were impossible. While the British officers talked about importing designs and waiting for foreign expertise, Watson saw something they missed completely. Australia's railway workshops had been building heavy machinery in brutal heat for decades. They had precision casting equipment that could form complex metal shapes. They had skilled workers who understood how to design for extreme conditions. They had engineers who knew the outback wasn't just hot, it was different. And different conditions required different solutions. Watson didn't say much in that first meeting, but his mind was already working on an idea that would shock the military establishment. Australia didn't need to copy British or American tanks. Australia needed to build something entirely new, something designed specifically for Australian conditions, by Australians who understood those conditions better than any foreign expert ever could. The other officers dismissed him politely and moved on to discuss more conventional plans. They thought Watson's idea was interesting but impractical. They expected him to accept their judgment and return to his normal duties. They were wrong. Watson's insight had planted a seed that would grow into something extraordinary, and he had no intention of waiting for permission to prove it. Watson didn't wait for permission. Within a week of that first meeting, he travelled to the New South Wales Government Railways workshop in Chullora, a suburb of Sydney. The massive brick building stretched across acres of land, filled with the sounds of hammering metal and hissing steam. Railway workers had built locomotives here for 50 years. The air smelled of hot oil and welding smoke. Watson walked through the facility, studying the equipment with careful eyes. He saw massive casting furnaces that could pour molten metal into complex moulds. He saw precision machinery that could shape steel to exact measurements. He saw workers who had spent their entire lives solving mechanical problems in the harshest environment on Earth. Watson recruited Frank Cummins to lead the design work. Cummins was 38 years old, a locomotive designer who had never seen a tank blueprint in his life. He knew nothing about armour thickness or gun turrets or military specifications, but he knew everything about building machines that could survive the Australian outback. He understood cooling systems, weight distribution, and how to design equipment that ordinary mechanics could repair with basic tools. When Watson explained the project, Cummins studied him for a long moment, then nodded once and said they should start immediately. They began work in February 1942 with nothing but blank paper and measuring tools. Cummins sketched designs on a drafting table while Watson calculated armour thickness and gun specifications. They decided to use 3 V8 engines, each producing 117 horsepower, for a total of 351 horsepower combined. These weren't specialised military engines that would take months to manufacture. They were modified Cadillac truck engines that Australian factories already knew how to build and repair. Any motor mechanic in the country could work on them. The armour design broke every conventional rule. British and American tanks used welded steel plates, dozens of pieces fitted together like a jigsaw puzzle. Each weld was a weak point where armour could crack under impact. Cummins proposed something radical. They would cast the hull in just 4 large sections, pouring molten steel into moulds like they did for locomotive parts. The casting process would create armour that was one solid piece with no weak seams. Watson calculated the thickness at 65 millimetres for the front armour, matching the protection of German Panzer IV tanks that were dominating battlefields in Europe and Africa. Military experts laughed at the design when they saw it. British tank specialist Major Kenneth Maxey visited the workshop in March and walked around the mock-up shaking his head. He called the design primitive and questioned whether railway workers could possibly understand the complexities of armoured warfare. American military advisers sent reports to Washington describing the project as a waste of resources. They argued that cast armour was weaker than welded plate, that using commercial truck engines was amateurish, and that Australia should abandon this foolish experiment and wait for proper American tanks to arrive. But Watson had one crucial supporter who mattered more than all the critics combined. General Sir Thomas Blamey commanded all Allied land forces in the Pacific Theatre. He was a hard man who had fought in World War I and had no patience for theories that didn't work in practice. Blamey visited Chullora workshop in April and spent 3 hours examining the designs, asking detailed questions, watching the workers prepare casting moulds. He understood that Australia was running out of time. He understood that American tanks were failing in Australian conditions. He understood that sometimes the best solution came from unexpected places. Blamey gave Watson authorization to build a prototype with one condition. Watson had 4 months to produce a working tank. If it worked, the Army would order 100 units. If it failed, the project would be cancelled and Watson would return to normal railway duties. 4 months to design and build something that normally took years. Watson accepted the challenge without hesitation. The workshop transformed into a 24-hour operation. Workers poured the first armour castings in late April. The molten steel glowed orange-red in the darkness, flowing into massive sand moulds that had taken weeks to prepare. The heat from the furnaces made the building feel like the inside of a volcano. Men worked in shifts around the clock, sleeping in cots near their workstation so they could return immediately when needed. Cummins barely left the facility, eating meals at his drafting table, solving problems as they emerged. They assembled the engines in May, bolting the 3 V8 motors together in a configuration nobody had ever attempted before. The transmission came from commercial trucks. The suspension used springs and bogies adapted from railway equipment. Every component was chosen for 2 reasons. It had to work in extreme heat, and it had to be repairable by ordinary mechanics with common tools. No specialised parts that would take months to order from overseas. No complex systems that required factory-trained technicians. On June 24, 1942, exactly 138 days after Watson first sketched the initial design, the first AC-1 Sentinel rolled out of the workshop into the morning sunlight. The tank was smaller than the American M3 Grant, with a lower profile that would be harder for enemy gunners to hit. The cast hull had a smooth, rounded appearance, unlike the angular welded tanks from America and Britain. The name Sentinel was painted on the side in white letters. Workers and engineers gathered around it, tired and covered in grease, watching as the test driver climbed into the commander's hatch. The engine started with a deep, throaty rumble. Not the harsh diesel clatter of American tanks, but a smoother mechanical sound from the three V8 motors working together. The tank rolled forward slowly at first, then picked up speed, its tracks clanking against the concrete yard. It turned, accelerated, stopped, reversed. Every movement was smooth and controlled. The crowd of workers began to cheer. The real test began immediately. Engineers measured everything with precise instruments. The ground pressure was 12.4 pounds per square inch, lower than the American M3 Grant's 14.2 pounds per square inch. That difference meant the Sentinel wouldn't sink into soft desert sand the way heavier tanks did. They ran heat tests in a specially built chamber that simulated outback conditions. At 122 degrees Fahrenheit, the Sentinel's cooling system kept the engine running perfectly. American M3 Grants overheated and shut down within 45 minutes at the same temperature. The armour tests produced the most surprising results. Engineers fired artillery shells at cast armour samples and welded armour samples of the same thickness. The cast armour proved 15% stronger, exactly the opposite of what conventional wisdom predicted. The single-piece construction distributed impact force better than welded seams. Major Maxey had been completely wrong. On July 15, 1942, just 3 weeks after the first prototype rolled out, the Army authorised production of 65 Sentinel tanks. Australian workers who had never built a tank before had proven they could match or exceed the world's leading military manufacturers. Over the next 5 months, as production ramped up and the Sentinel proved itself again and again, the question became whether the rest of the world would let them continue. By December 1942, the Chullora workshop had transformed into a full production facility that operated with stunning efficiency. 4 complete Sentinel tanks rolled off the assembly line every single week. The same workshop that had previously built 2 locomotives per month was now producing sophisticated armoured fighting vehicles at a pace that surprised even Watson and Cummins. Workers moved between stations with practice coordination, each person knowing exactly what needed to happen and when. The sound of riveting hammers, welding torches and engine tests filled the air from dawn until midnight. Young men and women who had been building train parts 6 months earlier were now assembling gun turrets and armour plate with expert precision. The production numbers revealed something remarkable about Australian manufacturing capability. American factories required 55,000 man-hours to build a single M3 Grant tank. The Chullora workshop produced each Sentinel in 38,000 man-hours, a 31% improvement in efficiency despite these workers being first-time tank builders. The difference came from the design itself. Fewer parts meant faster assembly. Commercial components meant no waiting for specialised military suppliers. Cast armour sections meant no time spent welding hundreds of small plates together. Watson's insistence on simplicity and repairability had created a tank that was not only better suited for Australian conditions, but also faster to manufacture. Then the opposition began, and it came not from enemies, but from allies. Officials at the United States War Department in Washington learned about the Sentinel program and immediately saw a threat. American tank factories had contracts worth millions of dollars to supply Allied forces. If Australia could build its own tanks successfully, other countries might follow. British colonies in India, Canada, and South Africa might decide they too could manufacture their own armoured vehicles, instead of buying from America or Britain. The entire system of military manufacturing and profit would be disrupted. American diplomats began sending urgent cables to the Australian government. The messages used careful diplomatic language, but the meaning was clear. Australia should stop wasting resources on an experimental program and instead purchase proven American M4 Sherman tanks. The cables emphasised standardisation, suggesting that Allied forces needed to use the same equipment for logistical efficiency. They pointed out that Australia would need spare parts, ammunition and training that would be easier if everyone used American designs. The pressure was polite, but relentless, arriving in diplomatic pouches week after week. British military advisers joined the campaign against the Sentinel. Officials in London sent their own cables describing the Australian tank as adequate for training purposes only, unsuitable for real combat. These messages carried a tone of condescension, suggesting that colonial manufacturing could never match the quality of established industrial powers. The British War Office recommended that Australia abandon tank production entirely and focus on supplying raw materials like wool, wheat and minerals to support Britain's war effort. Let the real countries build the tanks, the messages implied. Australia should stick to what it knew. But battlefield reports told a completely different story, one that the diplomats and officials couldn't ignore or explain away. In March 1943, the Australian Army conducted extensive comparative trials in the desert near Alice Springs. They tested Sentinels against American M3 Grants in the exact conditions where tanks would actually fight if Japan invaded. The results were not even close. The fuel efficiency numbers shocked American observers. Sentinels travelled 1.8 miles for every gallon of fuel consumed. The M3 Grant managed only 1.3 miles per gallon. That 35% difference meant Sentinels could travel further, fight longer, and required fewer vulnerable fuel convoys to support them. In a country as vast as Australia, where distances between towns could span hundreds of miles of empty desert, fuel efficiency could determine whether a tank battalion could respond to an invasion or would run dry halfway to the battle. The heat tests were even more dramatic. Engineers ran both tanks continuously in 120 degrees Fahrenheit temperatures, the kind of heat that turned metal surfaces too hot to touch with bare skin. The Sentinels ran perfectly, hour after hour, their cooling systems managing the extreme conditions without any failures. The American M3 Grants began overheating within the first hour. By the end of the day, 40% of the M3 tanks had experienced engine failures, cracked radiators, or cooling system breakdowns. They sat silent in the red dust while their crews tried desperately to repair them with inadequate tools and replacement parts that would take weeks to arrive from America. The interior temperature measurements revealed why Australian crews preferred the Sentinel despite its smaller size. The centrally mounted engine design reduced internal temperatures by 22 degrees Fahrenheit compared to the M3 Grant. That difference meant Australian tank crews could think clearly, react quickly, and fight effectively instead of being half delirious from heat exhaustion. Soldiers who had trained in both tanks told their officers they would rather fight in a Sentinel any day. Lieutenant Colonel H.B. Taylor wrote the official report that summarised the trials. His words were careful and measured, as military reports always were, but the conclusion was unmistakable. The Sentinel maintains operational readiness in conditions that render American tanks' combat ineffective. In the Outback, our locally built tank is not inferior, it is demonstrably superior. Taylor sent copies of his report to Army headquarters, to General Blamey, and to the politicians in Canberra who were receiving pressure from Washington and London. On a blazing June afternoon in Darwin, the contrast between the two tanks became visible in a single scene that captured everything the numbers tried to explain. 4 Sentinels stood in formation on the red desert hardpan, their cast hulls gleaming dull grey under the harsh sun. The tanks looked ready for anything, their crews moving around them with easy confidence, performing routine maintenance checks. Nearby, just 50 yards away, 2 M3 Grants sat completely idle. Steam rose from their engine compartments where coolant had boiled over and evaporated. The American tank crews had given up trying to keep them running in the midday heat. They sat under canvas tarps stretched between the tanks, seeking any shade they could find from the 120 degrees Fahrenheit temperature. The sound difference was striking. The Sentinel's triple V8 engines produced a distinctive mechanical purr, smooth and steady, three motors working in perfect harmony. When the M3 Grants were running, their diesel engines made a harsh, rattling clatter that sounded angry and strained. Australian ground crews serviced the Sentinels in 15-minute intervals, quick checks that kept everything running smoothly. The modular design meant that if an engine did fail, mechanics could remove it and install a replacement in 45 minutes using standard tools. The M3 Grant required 4 hours of specialised work to access and remove its engine, and that was assuming the right tools and parts were available. By July 1943, production had reached 66 completed Sentinel tanks. An improved model called the AC-3 was entering testing, mounting a larger 25-pounder gun that measured 87.6 millimetres. The new version promised even better performance. Australian engineers were already designing a third generation with additional improvements based on crew feedback and operational experience. The program was succeeding beyond anyone's initial expectations. Then politics crushed technical excellence. The Australian government, facing enormous pressure from Washington and London, made a decision based not on battlefield effectiveness, but on diplomatic relationships and post-war planning. On July 7, 1943, officials announced the cancellation of the Sentinel program. The official reason given was standardization with American equipment. The real reason was that continuing the program would damage relationships with powerful allies whose support Australia needed for the long war ahead, and so ended one of the most remarkable manufacturing achievements in Australian history. The 66 Sentinel tanks never fired a shot in combat. They sat in motor pools and training facilities, used to teach Australian crews basic tank operations, then gradually moved into storage as the war shifted away from Australian shores. The Japanese invasion never came. The crisis that had sparked the entire program faded as American forces pushed back enemy fleets at Midway and Guadalcanal. By 1944, the Sentinels seemed like relics from a different era, solutions to a problem that no longer existed. Workers at Chullora Workshop returned to building locomotives. The casting furnaces that had poured armour plate now made railway parts again. The specialised tools and jigs were packed away in storage buildings where dust slowly covered them. But the impact of those 138 days of frantic work in 1942 rippled outward in ways nobody predicted. The same locomotive workshops that had built tanks in 18 months became the foundation of something much larger. Australian engineers who had mastered cast armour techniques didn't forget what they had learned. They applied those same principles to civilian manufacturing. The heavy mining equipment industry in Australia exploded after the war ended. Companies that had never existed before 1945 suddenly started producing bulldozers, excavators and mining trucks using casting methods developed for the Sentinel program. The cast armour technology proved revolutionary in ways that had nothing to do with military applications. Australian mining companies needed equipment that could survive the brutal outback conditions that destroyed imported machinery. They needed vehicles that could operate in 120 degrees Fahrenheit heat, resist abrasive dust, and keep running for months without major repairs. The engineers who had built the Sentinel knew exactly how to design for those requirements. By 1950, Australian-made mining equipment was being exported around the world. Companies in South America, Africa, and the Middle East discovered that Australian machines lasted longer and required less maintenance than equipment from America or Europe. The metallurgy breakthrough had even wider implications. When Australian engineers proved that cast armour was actually stronger than welded plate, they challenged decades of accepted engineering wisdom. At first, American and British tank manufacturers dismissed the findings, protecting their existing production methods and investments in welding technology. But by 1955, the evidence became impossible to ignore. The American Army began switching to cast hull construction for their new tank designs. The M48 Patton tank which entered service in 1953, used cast armour sections based directly on principles the Sentinel had demonstrated 11 years earlier. British tank manufacturers followed soon after. The humble Australian railway tank had transformed global armoured vehicle design, even though few people recognised the connection. Colonel Watson received a promotion to brigadier in 1944, a recognition of his service that came with no public fanfare or acknowledgement of what he had accomplished. He continued working in army logistics for the rest of the war, managing supply chains and equipment distribution. After the war ended, he returned to civilian life and railway engineering. He never spoke much about the Sentinel program. When people asked about his war service, he would mention some details about supply operations, but rarely discussed the tank project that had consumed his life for those crucial months in 1942. Watson died in 1962 at the age of 61. His obituary in the Sydney newspaper mentioned his railway career and his army service, but devoted only one sentence to the Sentinel, describing it as an experimental tank project that never saw combat. There was no mention of the 138-day miracle, no discussion of how he had proven that a colony could match the industrial powers, no recognition that his design had eventually influenced tank manufacturing worldwide. He was buried in a quiet cemetery with military honours that acknowledged his rank but not his innovation. Frank Cummins lived longer, returning to locomotive design after the war and working well into the 1960s. He incorporated cooling systems derived from tank technology into commercial railway engines. Those engines operated successfully in Middle Eastern deserts through the 1970s, proving once again that the Sentinel's engineering principles worked in the harshest environments on Earth. Cummins never received patents for his innovations. The work had been done for the government during wartime, so all the designs became public property. He retired in 1968 with a modest pension and the quiet satisfaction of knowing his locomotives ran reliably in places where other designs failed. Only in 1976, 34 years after the first Sentinel rolled out of Chullora workshop, did the Australian War Memorial officially acknowledge the program's significance. A new exhibit opened describing the Sentinel as the most significant Indigenous military innovation of the Pacific War. Historians began researching the project, interviewing surviving workers and engineers, piecing together the full story from dusty files and fading memories. The public learned for the first time about the railway workers who had built tanks, about Watson's impossible deadline, about the comparative trials that proved Australian engineering could surpass American and British designs. The story revealed profound truths about innovation under pressure. When a nation faces existential crisis, conventional wisdom becomes a luxury it cannot afford. The experts said Australia couldn't build tanks. They said it would take years. They said colonial manufacturing couldn't match industrial powers. They were wrong about everything because they were thinking in terms of normal circumstances and normal timelines. Watson and Cummins weren't bound by those assumptions. They looked at the problem with fresh eyes, asked what actually needed to happen, and then made it happen using the resources and knowledge they already had. The Sentinel succeeded because Watson had permission to ignore experts and courage to attempt the impossible. Nobody told him he had to copy British designs or wait for American blueprints. Nobody forced him to use welded armour because that was how everyone else did it. He was free to innovate from first principles, to ask what a tank needed to function in Australian conditions, to design something completely new. That freedom, combined with desperate necessity, produced a vehicle that surpassed anything the established powers had created. But the story also teaches a harder lesson about politics and power. Technical excellence doesn't guarantee success when larger forces are at play. The Sentinel was cancelled not because it failed, but because it succeeded too independently. Australia's allies couldn't allow a colony to demonstrate that it didn't need them. The political and economic implications were too threatening. Standardisation became the excuse, but control was the real reason. The best tank for Australian conditions was sacrificed to maintain alliance relationships and protect established manufacturing interests. In 2025, as nations again debate defence industrial independence versus alliance supply chains, the Sentinels story remains urgently relevant. Countries must choose between building their own equipment designed for their specific needs or purchasing standardised equipment from powerful allies. The choice involves not just military effectiveness, but political sovereignty, economic independence, and technological capability. The Sentinel proved that smaller nations can innovate and manufacture world-class military equipment when necessity demands it. The question is whether they will be allowed to. The last operational Sentinel sits in the Australian War Memorial in Canberra, preserved behind velvet ropes where visitors can walk around it and read informational plaques. The tank looks smaller than people expect, its cast hull smooth and curved, its profile low and purposeful. A brass plaque mounted on the display stand bears 9 words, "Built by Australians for Australia in 138 days." Those words don't tell the complete story of political pressure, technical innovation, and missed opportunity. They don't explain how railway workers became tank builders or how their creation influenced global manufacturing for decades. They don't mention Watson dying largely forgotten or the diplomatic cables that killed a superior design. But perhaps those 9 words capture the essential truth that matters most. When survival hangs in the balance, ingenuity matters more than pedigree. When the experts say something is impossible, sometimes the only people who can achieve it are the ones who don't know enough to believe them. The Sentinel stands as a monument not to military victory, but to human adaptability, to the power of necessity, and to the quiet courage of ordinary workers who built something extraordinary because their country needed it, and nobody else would help them.